Good morning. Today's topic is the theory of individual behavior, which is chapter 4 in the Bay textbook. There is a lot of math in this chapter once again, but in this particular chapter, we don't have to focus too much on the formulas. You basically want to be able to diagram things out. Very easy to do if you put the data into Excel and then think conceptually about the relationships between the different variables. Consumer behavior is very important. It's something you'll be studying in your marketing class as well if you've not done so already. What we want to focus here on is the math behind consumer behavior and why people may behave in a certain way. These are just some recent articles on evaluating real estate, the real estate sector, and how people's buying behavior may change depending on what's happening with interest rates and tariffs and everything else that's going on in the world. This is a recent article on how tariffs are changing consumer behavior overall, not just in real estate. So it's a very important topic to take a look at. I'm going to do the learning objectives a little differently than they are in the book. I'm just going to break it down to about 3. We want to basically understand how consumers make choices, given that they have different things that they can choose to buy. What matters is what they prefer one product over another. We could look at the myriad of products and things that a consumer has to buy, food, clothing, housing, etc. But we typically focus on 2 products at a time, because then we can diagram it and see how things that we might do as managers might change their behavior. So we want to understand, for example, how their individual behavior may change if we make a pricing change or if we offer a particular type of a discount, buy one, get one free, those types of things. So we want to understand how consumers behave and what's the likely impact from changes that we might make as a manager. And then all of that's going to be rolled into our firm level planning when we get into the next chapter and focus on our different types of cost and how profits are determined. So consumer opportunities are basically the set of possible goods and services that consumers can afford to consume. And then consumer preferences helps us determine which set of goods and services they actually will consume. So we have some properties of consumer preferences. Basically, one way to think about this in your other finance classes, you'll talk about investors being rational. The same thing holds for consumer preferences. Consumers' preferences should make sense. They should be rational individuals. So, for example, they should be able to express which goods are preferred over others. So we say that if there's 2 possible products or 2 possible bundles of products, we should be able to say which one we prefer to the other. So if we say A is preferred to B, the notation is basically it looks like a greater than sign, but it has a little bit of a curve there. It basically means A is preferred to B. On the other hand, if we prefer B, then we would say B is greater than or B is preferred to A. If the consumer is indifferent between A and B, if they're perfect substitutes, then we basically say A is approximately equal to B. That's the tilde symbol here. So A is approximately the same as B, so they basically have no preference of one over another. So that's the property of completeness. We also assume that consumers prefer more than less. And so I'm giving you 4 possible bundles here initially, A, B, C, and D. So let's say this is an undergraduate student at George Mason, and they are able to express their preferences for 4 potential bundles from the local pizza shop for Friday night. Bundle A has 1 pizza and 9 cans of soda. Bundle B has 2 pizzas and 6 cans of soda. Bundle C has 3 pizzas and 4 cans of soda. Bundle 4 has 4 pizzas and 3 cans of soda, and we're assuming that they can afford all of these bundles. Their indifference curve would look like this. We're basically, in this particular case, this student is indifferent between these 4 bundles. They would get the same amount of satisfaction regardless of what those bundles are. Let's say that we introduce bundle E, which contains 1 pizza and 6 cans of soda. Well, if we compare that to this curve, which we call an indifference curve, because they're indifferent between A, B, C, and D, if we introduce E, then what's the likelihood assuming it's the same price, what's the likelihood that they would choose E instead of A, B, C, or D? It's extremely unlikely. If they're rational, they shouldn't want E, because if we look at E has 1 pizza and 6 cans of soda. If it's the same price, they can get A, which has 1 pizza and 9 cans of soda. Or they could get B, which has 2 pizzas and still has 6 cans of soda. So A and B are both preferable to E because more is better. So we typically assume that consumers' preferences are more rather than less of a particular good. If the bundles are the same otherwise, they should select the bundle that has more of one good in it than the other. We also assume, and we're going to use the same graph here, that there's a diminishing marginal rate of substitution. So what that means is, assuming they're indifferent between these 4 bundles, A through D, as they move from, say, bundle A to bundle B, you'll notice that they're getting 1 more pizza in the bundle, and they're giving up 3 cans of soda. So as we move from bundle A, they go from 1 pizza to 2 pizzas. So they gain 1 pizza, but they have to give up 3 cans of soda. That's a marginal rate of substitution of -3. For every additional pizza, they're willing to give up 3 cans of soda at this point on the curve. But notice what happens if we move from B to C. We get 1 more pizza, but we're willing to give up only 2 cans of soda. So once we have a particular level of a particular good, then to get more of it, we're a little less interested. So we're willing to give up less of whatever our other possible choices are. So the reason that this curve is shaped the way it is because there is a diminishing marginal rate of substitution. So we have this convexity to the curve because of that. If we go down here to go from bundle C to bundle D, we're getting 1 more pizza, but we're only willing to give up 1 can of soda in this case. That's because of the diminishing marginal rate of substitution. We also assume, and this really gets to rationality, that let's say we have 3 bundles, A, B, and C, and the consumer prefers A to B and prefers B to C. Then logically, A should be preferred to C. So that's transitivity. If A is greater than B, A is preferred to B, and B is greater than C, B is preferred to C, then A must be preferred to C. On the other hand, if they're indifferent between A and B, and they're indifferent between B and C, they should be indifferent between A and C. So these 4 properties basically help us to graph these things and figure out what investors or what consumers may do in particular circumstances. We're basically assuming that they're going to exhibit some sort of rational behavior. So one of the big tools here, there's 2, indifference curves and budget curves, but the first one is this indifference curve. So, quantitatively, we don't know everyone's indifference curve. We can't necessarily put a mathematical formula on it, but by creating these indifference curves and graphing them out, it helps us understand what likely behavior is. So remember, an indifference curve means that for all of the bundles that are on this curve, we're indifferent between them. So here we have bundles A and B and C. We're indifferent between those three bundles. Which one we choose will depend on how much money we have to spend. All right, and we'll get to that in a minute. But we're indifferent between A, B, and C. If there's another bundle down here, D, we're not going to pick it. Anything below this line would not be of interest to us because we remember that more is better. If we choose these bundles up here, then we're going to be happier. We're going to have a higher level of satisfaction, or in economics, we call that utility. So individuals actually have multiple indifference curves. So I gave you this curve earlier for the bundles A, B, C, and D, and those are repeated here. But now I'm putting another indifference curve up here that is the same proportion in the bundles as bundle A. So I've simply doubled everything. 2 pizzas versus 1 pizza, 18 sodas versus 9. So if you're indifferent between A, B, C, and D, then you also are going to be indifferent between E, F, G, and H. So how many indifference curves does an individual have? They're actually infinite, all right? There's many, many curves potentially between this curve and this curve, assuming that we could infinitely divide pizzas or infinitely divide cans of soda, which obviously we can't in this contrived example, but there's not a single indifference curves. Individuals have many indifference curves between particular choices that they're going to make, but what you'll notice is the shape is the same. And so you could think of these indifference curves, drawing them in between, and they're not going to intersect each other, but they're going to be higher as you move from the left to the right. And so obviously we'd be more satisfied with the highest indifference curve. The higher the indifference curve, the more satisfied we are. You know, if we had unlimited money, then we would always choose an indifference curve way out here to the right. Unfortunately, we don't have an infinite amount of money. We have a limited amount of resources. And that's where our budget is going to come into play to figure out which indifference curve is going to be the one that we're going to use to evaluate what the consumer's behavior is likely to be. So that's where we come to constraints. So we have lots of constraints, but the big constraint in terms of consumer behavior is their income or their budget. How much do they have to spend on these different bundles of products? So let's say that our income or our budget is M. That's the amount we have to spend. And let's assume that we're only going to spend that budget on 2 goods, X and Y. Then the total amount that we're going to spend is going to be the price of X times however many of X we're going to buy, plus the price of Y times however many of Y we're going to buy. And that sum has to be less than the income we have to spend, less than the budget that we have available. And so the highest amount that we can spend is going to be when the price times the number of X we choose plus the price times the number of Y we choose is exactly equal to our consumer income until we've exhausted all of that income. So I told you I was going to do too many formulas today, so we're going to leave it at that, and we're going to move on to a diagram. And so this is what the budget set looks like, all right? So over to the left, if we wanted to buy nothing but Y, we would basically take the total budget divided by the price of Y, and that would tell us the maximum amount of Y that we could buy, assuming we buy none of X. And then over here to the left, assuming we were going to spend our entire budget on X, we would take that budget and divide it by the price of X, and that would tell us if we don't buy any of Y, if we put all of our money into X, how many units of X we would buy. And so the budget set is going to be this straight line between those 2 points. It basically tells us what proportion of X and Y we can buy given the limited amount of budget that we have total to spend. So this is an example. Let's say we're going to keep it very simple. We have a budget of $10. That's how much we have to spend. And good X costs $1 per unit, and good Y costs $2 per unit. So if we look at X, if we take the entire $10 and buy X, we can buy 10 units. On the other hand, if we take the entire $10 and buy Y, we can buy 5 units. And so we can draw this budget line, and that tells us basically the different proportions of X and Y we can buy to spend our $10. So in the case of point B, we would buy 2 units of X and 4 units of Y. In the case of A, we would buy 4 units of X and 3 units of Y. Both of them would cost us $10. Okay, so the previous curve, the indifference curve, tells us what our preferences are, but then the budget line is our constraint. That's how much we have to spend. And so there's only certain bundles that we can actually afford. And so when we put the indifference curve together with the budget line, we're going to match up the consumer preferences with that constraint. Okay, so what happens to this budget line if our income increases or decreases? All right, it's actually just going to shift to the left or the right, just like we had with supply and demand. If we have a higher level of income, then we can buy more of Y or more of X or more of both of them. And so an increase in income is going to shift this line out to the right. That's the budget line. On the other hand, if our income goes down, then we're able to buy less of X or Y, and that line is going to shift to the left. The slope stays the same, but it's going to shift to the left. I should go back here to the previous slide, though, and just note that the slope of this line is -2. The slope is basically the price of X over the price of Y. That relationship is the slope of this budget line, which is a -1/2 in this case. Okay, so these 3 lines have the same slope. The price of Y and the X of Y determine that slope. The prices aren't changing. Here, the income is changing. If our income goes up, the line shifts but has the same slope. The income goes down, the line shifts to the left but has the same slope. What happens if one of the products has a change in the price? Well, let's say that we decrease the price of good X. What's going to happen is this is our initial budget line. This is how much we can buy of Y and X, given the amount of money we have to spend. But if the price of X goes down, we can actually buy more for the same dollars. So if the price of X falls, the budget line is going to shift a little bit outward at the bottom. Well, a little bit outward at the top, but a lot at the bottom, because only the price of X is changing. Price of Y doesn't change, so this point stays exactly where it is, but we basically stretch this line out to the right, and our new budget line has a less steep slope, and we can buy more of X for every bundle that we have a preference for. So let me put this into the previous example. So remember the previous example, X cost $1 and Y cost $2. So this was our prior budget line. We could buy 5 units of Y and none of X, or we could buy 10 units of 10 units of X and none of Y. In the new budget line, X is now only costing us 50 cents. All right, so we cut the price in half of X. The amount we can buy of Y stays the same if we buy nothing but Y, but the amount we would buy of X increases to a maximum of 20 if we don't buy any Y. And so our budget line is stretched out to the right and has a less steep slope. In this case, the slope was -1/2. In this case, the slope is -1/4. All right? So consumer equilibrium is where the budget line is going to intersect with the indifference curve. So it basically will tell us when the marginal rate of substitution, which is based on the indifference curve, equals the marginal rate of substitution, which is the marginal rate of substitution versus the market rate of substitution. So the marginal rate of substitution is the slope of the indifference curve. The market rate of substitution is the slope of the the budget line that's determined by the market, okay? So that's this slope here. When those two are equal is where the indifference curve is going to touch the budget line. So again, remember, consumers have multiple indifference curves. So we have 3 indifference curves here, but now we are putting the budget line through those curves, all right? So notice this indifference curve here, indifference curve 1, crosses the budget line at A. So we could afford to buy bundle A, and we would be happy. On the other hand, we have lots of indifference curves. So this indifference curve, which is another one at a slightly higher level, indifference curve 2, would intersect the budget line at B. And we would be happy with that because we're indifferent between all the bundles on that curve. However, there's a higher indifference curve 3, that would intersect the budget line at C. All right. So which of these would we prefer? Would we prefer bundle A or B or C? We always want the highest indifference curve. And the highest indifference curve is curve 3. It's always going to be the curve that just touches the budget line. All right. So even though we like A and we like B, we're going to like C a lot better. It's going to give us a higher level of utility because it's on a higher indifference curve. Now D, this line out here, there's an indifference curve going through D as well, but we can't afford it because our budget line is down here. D is not part of our opportunity set. We can't buy D, even though we would be more happy with it because there'll be an indifference curve out here that crosses through D. We can't afford it because of the budget line. So we're going to assume that a consumer is always going to want to buy the bundle that is on the highest indifference curve, but does not exceed the budget line. We call that consumer equilibrium. That's the point at which we're going to maximize the consumer's satisfaction or utility. So all of that is a long way of getting to where we want to go, which is, okay, what happens if we want to change prices? How does that impact consumer behavior? By thinking about these indifference curves, it helps us understand the likely impacts on consumer behavior from different activities. So in general, remember that if we increase prices, then we're going to reduce a customer's budget set. It's going to shift to the left. On the other hand, if prices decrease, we're going to expand the consumer's budget set. The new equilibrium is going to depend upon the nature of the goods. Are they substitutes or are they complements? So we're going to deal mainly with substitutes. So we have a choice between buying X and Y. We have certain preferences between X and Y. And so initially, assuming no price change, we are at this black line here. So we've got the budget line, we've got the indifference curve. So the optimal point for the consumer is point A, where we buy X0 units of X and Y0 units of Y. Now, if we decrease the price of good X and it's a substitute for Y, then by reducing that price of Y, remember, we're going to move this line, this point here, out to here. This line's not going to change because the price of Y stayed the same. we're able basically to buy more of X because of the lower price. So the line is going to shift, the curve is going to shift as well, and the new equilibrium is at point B. So it turns out, not surprisingly, that at point B, we can afford to buy a lot more of X. Turns out, though, because the price of X has gone down, we can also buy a little bit more of Y. And so the impact of decreasing our price is we're going to sell more of our product. All right, not surprisingly, the other side of the equation, which we'll get to in the next chapter, is what's the impact of that on our profits and our cash flow. But if we lower the price, we're going to sell more product because consumers are going to shift their preferences based upon the higher indifference curve, and they're going to buy a much larger proportion of X. But because they're paying less for our product, they're able to spend a little bit more on other products as well. Okay, so that is what a normal good or substitute would look like. We also have to, again, look at how the curves are going to change as our income changes. So this is for, again, a normal good. And so this is just an income change. It's not a price change. So the prices of the goods stay the same. So the slopes of these two lines are the same. All right. But because we have a higher level of income, we're going to shift from this black budget line and indifference curve out here to this blue budget line and blue indifference curve. Our income is higher, so we can afford more of both products. And so our budget line shifts to the right, and we're going to find a higher indifference curve at that point. Notice it's the exact same shape as this indifference curve because our preferences are the same relatively to those different bundles. So we're going to move from point A to point B. And when you look down, that means we're going to buy a medium amount more of X and a medium amount more of Y. So an increase in our income is going to increase the consumption of both X and Y. Similarly, if the income were to decrease, it would reduce our consumption of both X and Y. So now we're going to look at some examples of different decisions we might make as managers, and then try and figure out what we think is likely to happen to the quantity that consumers are going to demand of our products or our services, or other choices that our workers may make relative to decisions that we make as managers. So this is the example that's in your book about buy one pizza and get one free. So the specifics are that the offer that we're going to make is if you buy one large pizza, you get one free, but there's only one free pizza per customer. If you buy a small pizza, you do not get a free pizza. If you buy 3 pizzas, you only get one additional one free. So the most you can get is one free pizza. So we have our indifference curve and we have our initial budget line. So this black budget line is what it looks like before the offer. All right. This indifference curve is what it looks like before the offer. And so given this particular consumer preference curve, then the likelihood is that a consumer is only going to buy half of a pizza. So think of that as a small pizza. All right. Right now, customers only want to buy a small pizza. They don't want to buy a large pizza. So how can we get them to buy the large pizza? Well, one way we can do that is by offering them a free pizza if they buy a large, but not if they buy a small. All right. So what happens is the indifference curve, obviously, we're going to have to look for a higher one. But the first thing that happens is the budget curve is going to shift. So points A through D stay the same, but then instead of giving them one pizza here, if they buy a large one, we're going to let them have a free one. Then the budget curve is going to just have a straight line going out to the right, and then it's going to continue. So the budget curve goes from A to C to E, and then to F. So it's a jagged budget line. So as we might expect, that's going to allow us to hit a higher indifference curve. And so now for this particular consumer, given that they're getting a free pizza, they're going to move out to here. All right. And they're going to likely now buy a large pizza because they're going to get one free. All right. Now we could have just thought through that and said, okay, that makes sense without drawing the graph. But the graph it helps you understand the underlying mathematics that's going on sort of behind the scenes in someone's head that's going to induce them to buy 2 large pizzas effectively for the price of one when they only really wanted a small pizza. All right. So we're affecting their behavior. Question is, what's that going to happen to our profit? So from a consumer perspective, we're getting more for a little bit higher price, but we're getting a lot more. From a producer perspective, we're basically unloading 2 pizzas, and we're selling a large when we otherwise would have only sold a small. The question is, what's the additional cost of producing that one extra pizza? We'll get to that in the next chapter. Okay, what if you give somebody cash? So if you give somebody cash, then you're going to shift the line. This black line here is the budget line initially. If you just give them cash, say you give them $10 of cash, then the budget line is going to shift here to this light blue line, and they're going to have more income to spend. And so they're going to buy more of X and more of Y. But what if instead of giving them cash, you offer them $10 worth of X? All right. So as a marketing campaign, you could just give everybody cash, which they may not spend on your product, or you could give them $10 in your product. So what does that do? Then the budget line is going to go from here to A, it's going to shift out to B, and then it's going to continue to here. So in that scenario, they're going to have to use that $10 to buy our good versus the substitute, the alternative good. So from a producer standpoint, we don't want to give a cash gift because they're likely to spend that on something else. It's better to give an in-kind gift. On the other hand, we could offer them a gift card, but they have to use the gift card at our particular store. All right. And so if we're going to offer them the gift card, then we're going to shift the budget line from here out to here. So we're going to go from this black budget line, it's going to shift out to here, and then the slope is going to be, the slope is going to be the same. And the impact of that, if we give them a gift card that's valid at our store, is they'll move from A to C, and they're likely to buy more of X. Now, guess what? They're also going to buy more of Y, because the fact that our line is shifting out to the right means that if we're getting $10 of free goods at X, we have more money left over from our budget that we could also spend on Y. So that's going to help us, but it's also going to help our competitor. Okay, now let's look at management versus the worker. And so let's look at a worker's preferences. And in this case, we want to look at their leisure time versus the income that they're going to make from working. So in this situation, we're paying $10 per hour, up to 24 hours a day if somebody wants to work 24 hours. But when we graph this out, if they work 24 hours a day, we're paying $10 an hour. They would earn $240 for the day. If they decide they would prefer not to work and use those 24 hours for leisure, then their income is going to be zero. They're going to have 24 hours of leisure. So where do they land? They land where this budget line goes, the highest equilibrium curve, and it works out, again, a contrived example, that works out to be the point at which they're working 8 hours and they have 16 hours of leisure. So at that point, they would make $80, 8 hours times $10, and they would have 16 hours of leisure. all right? And that would be the worker equilibrium. They're not going to want to work an extra hour because they would have to give up too much leisure in order to do that. So the slope in this case, the wage rate, is the opportunity cost of leisure. For every additional hour that I work, that costs me $10. So that's the opportunity cost of leisure. So in order to get a worker to work more than 8 hours a day, then what we're going to have to do is offer them something higher that increases the amount they're getting to give up that leisure. So let's say we do a typical arrangement, which is we're going to offer overtime pay. So we're going to offer an additional $5 of pay for every hour over 8 hours per day. So this is our old budget line. It goes from $240 if we work 24 hours down to zero if we have leisure for 24 hours. So we have a perfectly straight line, all right? If we're going to offer $5 of pay for every additional hour worked, then their total pay opportunity goes up because of that additional $5 per hour. So you'll notice here that the line shifts. Okay, the slope is the same before and after, but it shifts at this point. This is the point at which they have 8 hours of work and 16 hours of leisure. That point is going to shift to here. And so if we think back to the indifference curve here, if we were to redraw this indifference curve, we can find that we can get to a slightly higher indifference curve, and it's likely going to touch at this point here. So likely that's going to result in everybody wanting to work about an hour of overtime, okay? Depending on the shape of the curve, it's possible the indifference curve could touch a little higher than that, but that would be enough of an incentive to get people to work an additional hour and give up that 1 hour of leisure. So all of these examples are how we take this theory, this abstract concept of an indifference curve, and then match it with the constraint that the consumer has, which is the budget. And we look at how changes we might make, discounts we might offer, sales, promotions, buy one, get one free. What do we have to do to encourage our staff to work a little bit harder, be a little bit more productive? There's some examples in the homework of the impact of providing healthcare coverage. All of those actions that we can take as a manager, we want to translate those into how we think the consumer or the worker is going to behave. So the whole point of this chapter is to understand individual behavior, which we can then model out to see what our actions might do in terms of their behavior. On the other end, we're also going to have to look at what it's going to do to our profits. And so in the next chapter, we're going to talk about the different types of costs, fixed costs, variable cost, and the like. And then we're going to bring that into play as well. So that's it for today, and I will see you in the next lecture.